AP Calculus, Unit 7, Day 59 notes. Our objective, finding integrals by substitution, including changing of variables and limits of integration. Okay, so the main idea with these problems is if I start with a function and then I take the derivative, we know how to do that. We're pretty good at that. We're really good at that. And now if I go back and take the integral, so I take the derivative, I should be going back to my original function. Obviously, this is indefinite integral, so I'd have to add a constant. But in theory, that's what we're doing here. And some of them are going to be tricky because we don't really know how to do that, but we're just going to kind of train ourselves. Oh, if I should just be going backwards, what am I looking for? All right. And there'll be some patterns that we're going to have to look for. After a while, they get easier, but they can be challenging up front. All right. So what we're looking at here, if I take sine of 3x, I use the chain rule. Derivative is cosine 3x times 3. Okay, so 3 cosine 3x. So now if I take the integral of this derivative, 3 cosine 3x dx, I know I'm going to end up with sine 3x, right where I started, and then plus a c. So we should just start noticing like what disappeared. Oh, the 3 disappeared. How's that related to something? Oh, there's an inside function that's 3x. Interesting, this relationship between those. All right, let's keep looking at these. So for this one, the derivative is e cosine x times negative sine x. This is e to the f of x times f prime of x. So we just write it's negative sine x e to the cosine x. So now when I want to do the integral of this, again, I know that I'm going to go back to my original problem, which will be just e cosine x plus c, and I should see, oh, so in order just to go backwards, I need to have this here, and that's what we're trying to figure out. How do we make that relationship? So just a little reminder, the derivative of natural log of u is equal to u prime over u, or natural log of f of x is f prime of x over f of x. So right here I have natural log of x squared plus 3. So in the numerator is 2x, and the denominator is x squared plus 3. So now when I take the integral of this derivative, I know I'm going to end up going backwards and getting the natural log of x squared plus 3. Oops. And whenever we go backwards, we always want to write it in absolute value. But so when I take the integral of this, it's going to be the natural log of x squared plus 3, right, what we started with, and then plus a c. So again, this 2x is here, and we kind of gave ourselves a little hint of where that 2x came from. All right, let's look at the last one. So just first write it to the 1/2 power. And notice we got x squared plus 3 over here and x squared plus 3, so that's good. So the derivative is equal to, using the chain rule, 1/2, so you bring the power out and then subtract. So we take the derivative of the outside function, leave the inside function the same, and then multiply by the derivative of the inside function. So now when I simplify this, so simplify 1/2 times 2 cancels out, x is in the numerator, and then I took the whole function x squared plus 3 that's raised to the negative 1/2 power, put it in the denominator, and made it become positive exponent. Okay? And now when I go backwards, and I'm taking the integral of this function, it looks very, very complicated. But hey, it should just be what we started with, and it's going to be. It's how do we recognize that? And these are constant. Okay, so this is where, with all of these, I took the derivative, then I undid it by taking the integral, and obviously when it's an indefinite integral, I have to add the constant of integration. Okay, but for all these, you're going to end up there. And again, we're going to start looking at, like, hey, how did this impact it? How did this impact it? What did this do? What did this do? Okay, so on the bottom of the page here, first thing we do is composition of functions. Again, we're talking about pattern recognition. So we knew way back when the chain rule was outside-inside rule. Take the derivative of the outside, so f became f prime, leave the inside the same, and then take the derivative of what was inside. That's chain rule. So what we're going to do now is we're going to go backwards. So if I'm going to end up with a composition of functions plus a constant, I need to start with f prime of g of x times g prime of x. So this is going to be key right here. That is our license to integrate. Okay, I can't go backwards until I find, first of all, I got to find what's my inside function. Okay, and when I know my inside function, then I got to make sure that the derivative is there. And then I got to identify my outside function. Okay, but identifying the inside function, let's go back and look. Inside function was x squared plus 3. Okay, that's there. Oh, its derivative is 2x. Okay, that was there, but it canceled out with the 1/2. Okay, so that exists, and I can go and I can multiply by 2, divide by 2, all that good stuff. So, but at least that allows me to do that. Okay, and that's more later on. Here, what's my inside function? The x squared plus 3. What's the derivative? That's the 2x. Up here, what's the inside function? Cosine x, because it's e to the cosine x. What's the derivative of that inside function? Negative sine x. Here, what's the inside function? 3x. The derivative is 3. Okay, so we're just identifying patterns. They're going to be hard for a little bit, but hopefully they get easier and easier. Okay? Okay, so I'm going to leave some of the work here, and I have a lot of stuff written here, but I'm going to try to talk through it for each problem. Okay, and I'll do some highlighting for some of these. So find each of the following indefinite integrals, which means you're going to end up with a C, by pattern recognition. Okay, so first thing I did was I just wrote up a quick reminder, obviously, that the integral of f prime of g of x times g prime of x is just f of g of x plus c. Okay, so that's what we're doing here. I'm going to undo both of these. All right, so one of the things we want to do, what's my inside function? It's cosine of 3x. I'm saying, hey, it looks like my g of x, and I'm trying to use this pattern. There's my g of x, that's 3x. What's my derivative? Cosine. Okay, and now what is my derivative? Hey, that shows up there. I have the red arrow there. So if that happens, then I can go to f of g of x. Well, what is the antiderivative of cosine x? That's sine. So it's going to be sine of 3x is my f of g of x plus c. That one's not too bad. All right, let's look at the next one. So we want to look, and same thing, what's my inside function? Ooh, that's got to be x squared plus 5. What's my outside function? The derivative of my outside function. Ooh, that's going to be 1/3, something to the 1/3 power, because it's a cube root. Okay, what is my g prime of x? If the g of x was x squared plus 5, then my g prime of x is going to be 2x. Okay, so I have this right here. So when we do the integral, the antiderivative, that's just going to disappear. So I'm going to put my g of x in first. Let me get rid of it here. So there's my g of x, x squared plus 5. So I put that there, and then how do I do the antiderivative of something to the 1/3 power? Well, I raise it up by 1, so it's the 4/3. Then I divide by 4/3, which is the same as multiplying by 3/4. So it's 3/4 x squared plus 5 to the 4/3 plus the constant. It looks tricky. But if you can just get these parts, hey, make sure everything shows up and then write it like this. Okay, let's go to the next step. Okay, so again, I have 2 sine of 2x plus 3 dx. So there's my inside function. That is right here. That's the g of x. Okay, what's the outside function? Sine of something. Sine of blank. Okay, sine of g of x. And what's the derivative of my inside function? That's just 2. The key is, do I have that license to integrate? Do I have everything? Yes, I do. There's my 2. So now all I have to do is, what's the antiderivative of sine? Negative cosine. What's the inside function? And again, I'm just getting that from right here. So that's why I get negative cosine of 2x plus 3, and it's indefinite integral. Don't forget the constant plus c. Okay, these are hard. So we're looking for inside functions. Which one is it? Well, I look, which one looks like it could be the original function, which one looks like it could be the derivative. Oh, if the original function is in the denominator, which I find x squared plus 2x, and then the derivative is in the numerator, I'm probably dealing with natural log. But this gives me the license to integrate, so then I can go backwards. And this is one where it's not necessarily inside, but when we go back and look what we talked about here, remember, it's the derivative over the original function. Okay? And then that's going to be the natural log of the absolute value. So we haven't talked about that enough. When I take the integral of something, it'll go backwards. It's going to be the absolute value of, and it should be x squared plus 2x. Sorry, I got to change that right now. So the natural log of x squared plus 2x, because that's the g of x. So the outside function, that ln x, doesn't show up in the derivative part. So there's our plus c. Okay? Let's look at the next two. And again, as a reminder. So now we are at, where am I here? Okay, so now my inside function is 3x plus 2. I'll get that here. My outside function's cosine. My derivative is 3. Ooh, I do not have a 3. So notice what I did. Inside the integral, I multiplied by 3. And then on the outside, I multiplied by 1/3, because 1/3 times 3 is just 1. So I didn't change the value. And with properties of integrals, say we can take a constant out. I'm going to leave the 3 in there because I want that, right? That's my license to integrate. And so now what do I get? This 3's here. So now we're going to end up getting the 1/3 stays. We do the 3x plus 2 comes down because again, let me go all the way back up. It's f of g of x plus c. The only thing is I just changed it by a factor of 1/3. So now we have 1/3 sine of 3x plus 2 plus c. All right, let's do this one together also. Okay, so I'm going to do this one on another page. There's a lot of writing there. I apologize for that. Hopefully you're able to follow along. Let's again remember what we're doing. When we were starting with f of g of x, we took the derivative, we got this. F prime of g of x times g prime of x. That's the chain rule. Now what we're doing is taking the integral and we're going back to the original, which will give us our f of g of x plus c. So I just need to identify a few things. The first thing is I got to identify, hey, what's my inside function? I know this looks like it's on the bottom of a fraction. I apologize. It's not. Okay, so g of x is going to be, I'm going to say what's under the radical. And that's because it's to the second degree. I just rewrote this. So it's the integral of 3x times x squared plus 2 to the 1/2 power. So the radical can be very confusing. Where now we can see, oh, our outside function is really the square root part, the something being raised to the 1/2 power. And now lastly, let's go back and let's look at, hey, what's g prime of x? Okay, that is 2x. All right, this is my license to integrate right here. I need this. I don't have it. I have a 3x. So 2 ways I can do this. I can either take the 3 out and just write everything else the same. And then multiply by the inside by 2, which is then dividing by 2, which is the same as multiplying by 1/2. And you should notice that I now get 3/2 integral of 2x times the x squared plus 2 to the 1/2 dx. Okay, and I said there's a couple ways you could do it. You could have also, oops, I'm trying to divide my notes over here with my work for the problem. I could say, hey, what times 3 equals 2? And I could have come in and I could have multiplied this by 2/3, because that would have got me to 2. And then I could have undid that by multiplying by 3/2 over here. So at the end, I get 3/2 on the outside, and I get 2 on the inside. So whatever way makes you feel more comfortable. I like fractions, so I usually do it this way, but I know I try to do it the other way. Some people struggle with that. Okay? So now let's go through and um, let's use our pattern right here. I know what my inside function is, and I can take the antiderivative of what my outside function, the derivative of that was, and then I can add my c. And this 3/2 just kind of travels along. So I'm going to get 3/2. I'm going to get, in my parentheses, I'm going to get x squared plus 2. Okay? And, plus. And this is my license to integrate, so I'm not doing anything with that. We said my outside function was right here, something to the 1/2 power, so let's take the antiderivative of that. Add that by, um, add 1 to it, gives me 3/2, then divide by 3/2 is the same as multiplying by 2/3. Okay, those will cancel out. And at the end, do plus c. So all that work just to get me to x squared plus 2 to the 3/2 plus c. Okay, but that's how we use patterns to solve these. All right, let's go back and look at those last two. Okay, so for the second and last one, 3x is my inside function, e is the outside function, the f prime, and g prime of x from g of x is 3. I don't write 5 down just because there's a 5 there. Whatever my inside function is, or one that's with the, connected to another part, that's what I take the derivative of. So I need there to be a 3 there. There is not. So what I did, I took the 5 out. I then went through and multiplied this by 3. I undid it by multiplying by 1/3. So let's finish this problem. Now this is 5/3. I now have my license to integrate this 3. I should have done yellow. But so now what do? I know it's going to be um, something to the, what's the integral of e to the 3x? It's just going to be e to the 3x. Okay, so because the derivative is e to the 3x times 3, and there is my 3. So I know the derivative of e to some power, when I go backwards, it's going to be that e to some power times the derivative, and I already had that 3 there. So that's our final answer. Last part, we got a lot going on here, so I wrote my inside function as 2x squared plus 3. I took the derivative of that, 4x. Oh, I have 3x, but we'll deal with that in a second. And what is my outside function? If I move this up, it would be something to the negative 1/2. So I could have rewritten that. And let's do that right now. So it's the integral of 3x to the 2x squared plus 3 to the negative 1/2 dx. And so that's my g of x. Then g prime of x is 4x, and then the function is something we erased, the negative 1/2. Okay? So I don't have 4x. How do I get that? I have 3. I'm going to undo the 3 by multiplying by 4/3. If I multiply the inside by 4/3, I'm going to multiply the outside by 3/4. Okay, multiply by 4/3, divide by 4/3, which is the same as multiplying by 3/4. Okay, so that's going to get me to the 4x, and that's my 3/4. And now I just go through, and the fact that I have my license to integrate now, I can just go backwards. Again, when I say go backwards, what do I mean? You can just say, hey, what's the antiderivative of that original outside derivative function? Let's find f. I know what my inside function is. That's going to stay the same as this g of x, and then add c. Okay, so any constants stay there, 3/4. What did I do? 2x squared plus 3, 2x squared plus 3. Now I just took the something being raised to the negative 1/2 power. I added 1. I used the power rule. So that goes from negative 1/2 to positive 1/2. We then divide by 1/2, which is the same as multiplying by 2. 3/4 times 2 is 6/4. Reduce to 3/2, and there's my answer. Okay, it seems like a lot. I know it is the first time you see it. It won't be bad. The nice thing is, if they have something like that, you'll have your notes there, and these practice problems, you'll be able to follow it through. And we're going to get into some use substitution for the second part of this section. I almost think that's easier. It's a little bit harder the first time we see it, but being able to see the pattern can be difficult. Okay, and then what if I can't work the pattern? What do I do? That's where we get into U substitution. All right, this is day 59, part 1. We'll go on to day 59,